Hello sir, my name is Bhakavendra Subbareddy and this is the task 1. My registration number 19BEC0523. So our first question is write and assemble an 8051 assembly level program to add the following data and then use the simulator to examine the CY flag. So let's go and see the aim. So our aim is to write an 8051 ALP to perform addition of 5-bit number using KEL software and to verify the result manually. So tools that we have that are required is firstly KEL software, and the second one is this. So let's see the algorithm. First number to be added, which is 19BEC0523, and using the mnemonic MOV and assign the first 2 bit numbers to the accumulator. So we have to do this, and next this is the flow chart, and this is the program. And output is register containing the result, register A containing the result of which is register RO and has a result of so this is the manual calculation that I have done. An observation, snip of the 8051 assembly level program with the comments and registers before execution. So this is the output before the execution, and after the execution this is snip of 8051 assembly level program which comments register after the execution, as I said before. So this is the output after execution. The highlighted part is the output, so I've highlighted it. And in inference to find the period of the machine cycle for 11.059 mHz crystal frequency. So this is the inference, and the total amount of required to do assembly level programming is this, and time required to execute each instruction given in table. So this is the table. Yes, and the amount of memory required to store the program is memory 30 bytes. And list of address mode and 4 types of instruction used, flag and register affected is in this table. Addressing modes used are direct 1, immediate 8, and indexed 3, direct indexed 4, register direct 3. The type of instructions used are data transfer 8, arithmetic 8, boolean 4, and flag affected is mostly no flag. So the result is the result of 8051 ALP to perform the addition of 5-8-bit number is executed along KEL software, and the results are verified using manual calculation. And for the second question, so we have to write and assemble an 8051 assembly level program to load the value to each of the register RO to R4, and then push each of these registers onto the stack and single step of the program, and examine the stack and the SP register after the execution to each of the instruction. So let's see. So this is the second one, and our aim is to write an 8051 ALP to load values into register R0 to R4, and then we have to then it have to be pushed onto the stack using KEL software. And tools, these are the tools required, and these are the algorithm, and this is the flow chart program. So the output is a stack pointer containing the result of R0. So I have written the outputs here, and this is the manual calculation. The calculation is nothing like, there's no calculation, manual calculation for this. So the output before execution is this, and after the execution is this. I've highlighted the output in the left side, as you can see my mouse I've pointed out. And the time required to execute each instruction is given in the table, and the amount of memory required to store the program is 21 bytes. So list of addressing modes, type of instruction used, and flag and register effectors is in there, like it is there in this table. The total amount of time required to add do assembly level programming is 17.376 years. And addressing modes used is direct 6 and immediate 5. Types of instruction used is data transfer 10, and flag affected is no flag is affected actually. So this is the result. And coming to the third question, so our aim is to write an 8051 ALP to set the stack pointer and store different values in different location of RAM, and then all of these values to be popped up back to the register using KEL software. So these are the tools required, and this is the algorithm that we have used. So this is the flow chart, this is the program, and this is the output. So there's no manual calculation for this. And observation table, like observation snaps before the execution, and these are the snaps after the execution. As you can see, the outputs that I have highlighted in the left corner, this is the output. And yes, the time required to execute each of the instruction is given in the table. So, and memory required to store the program in memory is 23 bytes. And list of addressing modes, type of instruction used, flag and register affected is in there, like it is there in the table. And addressing modes used are direct 7, immediate 5, and type of instruction used is data transfer 11. Flag affected, actually no flag is affected, and this is the result. And coming to the fourth question, so our aim is to write an 8051 ALP to set value into the register R0 to R4 and push them into the stack memory, and again pop them back into the registers using KEL software. So the tools required is only KEL software, and this is the algorithm and flow chart, a program table. So this is the program which is in the table, and output, this is the output, and there's no manual calculation for this as well. And observation, the snaps before the execution and after the execution, as you can see here. So I've highlighted the output on the left side, and up to pop, yeah. And the amount of memory required to store the program in memory is 31 bytes. Total amount of time required to do assembly level programming is this. Addressing modes used is direct 10, immediate 5. Type of instruction used is data transfer 15. No flag is affected, obviously. And this is the result. And our last question is, so let's see the aim. We have to write the 8051 ALP to set values into the register R0 to R4 and push them into the stack memory, and again pop them back into the register using KEL software. So the tool required is KEL software, and this is the algorithm. And this is the flowchart. So this is the program, and this is the output. I've done some manual calculation, as you can see here. And this is the snap before execution, and after the execution, as you can see here, I've highlighted the outputs in the left corner, you can see. So the amount of memory required to store in the program is 21 bytes, and total amount of time required to do, as you can see here. Addressing modes used is direct 1, immediate 5, index 2, register 3, arithmetic 3, branching 1, boolean 1. So type of instruction used is data transfer 3, logical 1, and mostly no flag is affected here, and this is the result.